Hello guys, welcome back to my channel. Now we're gonna look about this thing called boson. Of course we are questioning what are boson and so on as we travel in this journey. And a quick recap is that a boson is a particle that has a certain amount of spin associated with it. It's a particle whose spin is an integer, not a half. It's not a half, it's an integer full. And further, if what has bosons, there are subatomic particles such as photon, which are zero or integral spin and follows the statistical description of SN boson and Einstein. So we're going to talk about vector boson. Vector, what's a vector actually? Something which has magnitude and direction. And I don't know, very soon I will not be showing you in this board, but for today I'll show you for some reasons. So like this is magnitude. Magnitude is something that is everywhere, no? It's everywhere. I don't know how this light is coming like this, looking blur. Vector has a direction, like it's like here you can say it's pointing like this. It has a direction. So we're talking of vector boson. A vector has a magnitude and direction. I've told you what a boson is. A quick recap I gave you. So let's talk details about it. This is in relation to what we first said about gluon in the other video. Talked about gluon. What a gluon is. It's a type of elementary particle that mediates a strong interaction between quarks, acting as the exchange particle for the interactions. So now, following that, it says that gluons are massless vector boson. Massless vector boson. Now, if you are going to talk about vector boson, it means we are now going into details of what these gluons are, because they are the ones that are regarded as vector bosons. So, in particle physics, a vector boson is a boson whose spin equals 1. I've told you about this. Half spin integer, full spin integer. Vector bosons that are also elementary particles are gauge bosons. They have gauges, they are gauged. The force carriers of fundamental interactions. Some composite particles, you know what a composite, something which has more than one, made up of more than one. A quark, like for example, proton is made out, it has 2 up quark and 1 down quark, right? It's made of more than one particle. It's a composite. Now here it's saying some composite particles are vector bosons. Of course, if I ask you what is a vector boson, so you should have an idea if somebody asks you. It's a particle, in particle physics, a vector boson is a boson whose spin equals 1. And if you say what is a boson, I just told you right now. We are in an example. When somebody asks you what is an example of a boson, this includes fundamental particles such as photons, gluons, and W and Z bosons. The 4 forces carrying gauge bosons of the Standard Model, the Higgs boson, and the still theoretical graviton or quantum gravity. So we have done that in the previous video. I'm just trying to recap your mind as we go along this. So there are gauge bosons, the force carriers of fundamental interactions. So we are actually having vector boson also involved in these fundamental interactions, and some composite particles are vector bosons. For instance, any vector meson is composed as two quarks, and in parentheses with quark and anti-quark. For every positive there is a negative part of it, and that's why sometimes people argue that there must be another, we are having a parallel universe somewhere. And in this case, I don't know whether it exactly means the same universe as the one we are in, or is opposite to what the one we are in. Because if for every one thing there's the opposite of it. So suppose we say this where we are, our universe, the positive. Could there be a negative universe somewhere, a parallel one? Is this what it means? And what is really matter and antimatter? I don't have water. Excuse me guys, I think I have some water here to quench my throat as I talk. It becomes dry. So we are talking about vector bosons. We have WZ bosons, which I've told you what they are, their masses and so on from the other video. So we stop it there, because here we are dealing with definitions, just trying to make things clear. What is W boson? What are gluons? Gluons, vector bosons, what are bosons? Examples of bosons. Yeah, so now we're gonna deal with something called muons. We haven't talked anything about muons, so now we're gonna talk about muons. What is it in physics? What is a muon? Maybe I should be writing, sometimes accent might come in the way, and you say, what is this person? Say maybe somebody from another geographical part of the world who will not get my accent. Writing will show you clearly what I mean. M-O-U-N. This is muon. What is it? Now the muon is one of the fundamental subatomic particles. Is one of them. There are many, so this is one of them. The most basic building block of the universe, as described in the standard model of particle physics. The most basic building blocks of the universe. Okay, muons are similar to electrons. They are similar to electrons, but way more than 207. They weigh more than 207 times as much as an electron. So they have a charge, that means, but they weigh heavy. So you see these energies, come to think of it, it's just the weight. The quantity of it. What do you mean by weight? Is how much it weighs. So energy has weight, right? Because energy is equal to matter. And energy, which is composed of charges like electrons, electron or photon. When it's much photons, you have electron forming, and I guess antineutrino or something like that. We're coming to that. So yeah, muons are similar to electrons, but they weigh more than electrons, and we know what electrons are in the atoms. does it suggest actually that we may be having bigger atoms? Or maybe it's, for an atom it needs like, for example, when we have a proton and a neutron and an electron, we won't have a big electron muon in it. Muon cannot be part of an atom. Okay, I'm just wondering. The muon is part of the electron group, and I told you what the electrons are. Yeah, let me go get ahead a bit, explain to you, and then we'll continue. What are leptons? They are subatomic particles such as an electron, such as an electron, a muon, or neutrino, which does not take part in strong interaction. For that, you have to know what strong interaction, strong nuclear force is, and all that. So, yeah, are we still dealing with muons? So they are part of the lepton group, which I've just told you what leptons are. Leptons are a type of fundamental particle also, and I have told you what they are actually right now. In simple terms, what are leptons? From the previous video, if I can refresh your memory, leptons are elementary particles, which means that they are not made from any smaller particles. There are 6 known types of leptons, 12 if you count their antiparticles. 12 you count the antiparticles, so really coming there actually. So that's what muons are. Now let's go to something else. What is the difference between alpha decay and beta decay? Sorry, there's simply like call something. What's the difference between alpha decay and beta decay? Now, in alpha decay, the nuclear loses 2 protons. The nuclear loses 2 protons in alpha decay. In beta decay, the nucleus either loses a proton or gains a proton. Okay. Both alpha and beta decay change the number of protons in an atom's nucleus. Therefore, changing the atom to a different element. Changing the atom to a different element. Because they lose protons. You know, protons is part of the main thing that makes a nucleus, a proton and neutron. So when the protons are being lost, the element definitely is going to change. It won't be the same thing. So in alpha decay, it loses 2 protons. In beta decay, it either gains 1 proton, loses 1 proton, and that changes them to different elements. Are we together? So now we're going to talk about this what are leptons, which I've just repeatedly told you right now. They don't take part in strong interaction, and they are subatomic particles such as electrons, muons, which I've just told you muons, what muons are, or neutrino. Okay. Now, of course, they don't have. I just told you about leptons. I think we're gonna jump in to go to something else. What is tau? Tau. This one I'm gonna write it because I think it's entirely new. I'm looking at the time, guys, because noise do come around this time and we will get disturbed. So what is tau? We are taking a class, guys, so don't mind that I sometimes talk extra out of the video because I'm trying to get the whole picture around. What is this? This is tau. Now, do you know what tau is? Of course, if you are doing particle physics, you know it. But for somebody who doesn't know, who's seeing this for the first time, it's necessary that we define it so that somebody can understand who's watching this video. So tau is elementary subatomic particle. They are all elementary subatomic particles, forms of energies, quantized small packets, all that stuff. Now, what is tau? It's elementary subatomic particle, similar to the electron. It's similar, but it has this much. It has this much, 3,477 times heavier. This times heavier. In other words, sorry guys, the light is misbehaving. Just hold on a minute. I'm gonna put on this light. See, without light we can't see. That's why we say that light is so important in the universe. We can't see properly without light. I see my lamp, I didn't charge it, and it's saying, hello man, you didn't charge me. I'm gonna render the service. Let me see, just hold on a minute guys. I'm trying to focus things here. Right, now we can see. Of course we are seeing, but the light was not very clear. You have to see my face because it's me who's talking to you. Now, I was talking about tau. It's elementary subatomic particle, similar to electron, but it's 3,477 times heavier. So it's similar, it's this much. Otherwise it'd be, in simple terms, if you had to take off 3,046, then you'll have just an electron. You get what I'm saying? Because if you subtract 3,477 minus 3,476, you will be left with 1, and that will be 1 electron times 3,477. Are you getting what I'm saying? It's 3,000. This much, this times heavier. We're talking of weight here, isn't it? It's this much heavier, no? So must be kgs, heavier than an electron. Like the electron and the muon, which I've just told you, the muons. I know people forget very fast, so maybe I will just recap just now what I've told you. The muon is one of the fundamental subatomic particles, the most basic building block of the universe, as described in the standard model of particle physics. Muons are similar to electrons but weigh more than 207 times. You see, the muons are smaller. Now here we have gone to tau, which is much heavier. They are similar like electrons, but they are 3,477 times heavier than an electron, and of course now heavier than a muon, which is also similar like as an electron. They are similar to electron. So like the electron, muons, like the electron and the muons, tau is an electrically charged member of the lepton family of subatomic particles. And I've told you what the leptons are. Leptons are subatomic particles such as electron, muon or neutrino, which does not take part in strong interaction. Okay, so here he's saying that like the electron and muon. The tau is an electrically charged member of the lepton family of subatomic particle. The tau is negatively charged. That means it can take part in reaction, while its antiparticle is positively charged. So it has positive and negative. The negative is charged, and while its antiparticle is positively charged. What's the charge of a tau? So I've defined to you what a tau is. Now what is this charge we are talking about? Tau have a charge of -1 and can be written as tau, something like this. Actually, I don't know. It can be written like this, tau. Since antimatter has the opposite of charge of regular matter, and tauns have a charge of +1. So it's just giving you, because if tau has a negative charge, then anti-tau will be positive. So that's it, and can be written as T. This simple, just that I've given you here. It's not. No, it becomes positive. This is antimatter, anti-tau. This is tau, anti-tau. And I told you what tau is. This is the name that I've written to you. This is tau, which is 3,477 times heavier than an electron. Otherwise, it's like an electron, but it's this much heavier than an electron. Okay? Trying to make it clear for you to understand, guys. So it's written as T plus. Tauns themselves are unstable and can decay. So tau's, they are not stable and they decay because they are heavy, no? They are heavy, so they decay. Now, what is its mass? What's the mass of tau? We're going to detail about this tau. It's an important thing. So we gave it some kind of details necessary. What's the mass of tau particle? It's 1777 MeV electron volts. M standing for mega, I guess, electron volts. I'm not very sure about them, but EV means electron volts. It should be mega electron volts, because giga electron volt, mega electron volts, huh? Yeah. There is a third heavier type of charged lepton called tau. So is a lepton, of course, and the tau with a mass of 1777 MeV is even heavier than the proton and has a very short lifetime of about I think I want to clean this. It has a very short lifetime of 10 to -13 seconds. So imagine how small how short this time is. This is like 10 times 10 times 10 times 10 times 10, 13 times negative. You can see negative means 0 point. It starts from, you know, when you are writing a negative value, like in this case, when it's minus 0.000, you know, I mean minus negative, and it's this much short timed. It has this much short lifetime. Like the electron, let's go again because I've just talked about much. There is a third. Let me go from the beginning. What's the mass of a tau particle? It's 1777 MeV. There is a third there is a third heavier type of charged lepton called tau. The tau, with a mass of 1777 MeV mega electron volt, I guess, is even heavier than the proton, and has a very short lifetime of about 10 raised to the power minus 13 seconds. Like the electron and the muon, the tau has its associated neutrino. Of course, when electron anti, we have the neutrinos, the opposite of anything, you know. I don't know whether neutrino means the same thing or different here. Like the electron and the muon, the tau has its associated neutrino, which means the electron and muons also have their neutrinos. We're going to talk about neutrinos, don't worry. So what is the composition of tau? See, we're going deep down. Tau is defined as an intrinsically disordered protein. Now from there, now start to see things. It's protein, okay? IDP, and it's present as 6 isoforms in human brain. In human brain, in your brain, you find these taus there as 6 isoforms, ranging from 352 to 441 amino acid residues. Amino acids. When you talk of amino acids, like you're eating beans, there's amino acids in beans. In proteins, there's amino acids. Tau is found in your brain. This particle we are talking about. So, yeah, so that's why we left it. That's what tau is. Now, from now on, you know that you have a lot of tau in your brain, and it's a form of, it's actually protein. And this is the particle we're talking about. From the electron to how much it's like an electron, but weighs more than an electron. So these are electrons. When they're put together to a certain level, they make a protein. And you are made of these proteins. They are found in your brain in form of amino acids. When you hear that you are made of electrons, don't find it strange. It's real, what it is. You are made of electrons. When you give more and more weight to electrons, they make you. Let that sink in. So guys, I'm not going to go further than that because it will be too much to take for one day. We'll proceed. As you can see, it's quite interesting. It's getting more interesting. We're discovering a lot. I told you, stay tuned. You're going to get more, and you're getting it. So guys, stay tuned, subscribe to my channel, like and share and comment. Why are you not subscribing? Why do you just watch? Is it too difficult for you to do that? You just press that subscriber button. Only you are coming across this video by accident and you happen to like it. There are more like this. You just have to subscribe and go through my videos. You'll find a lot of interesting things there and more to come. Please subscribe to my channel and stay tuned. See you in another one. Bye for now. Love you guys. Bye.